Sharks, together with rays and skates, make up the subclass elasmobranchii of the chondrichthyes. Sharks differ from other elasmobranchs, however, and resemble ordinary fishes in the fusiform shape of their body and in the location of their gill clefts on each side of the head. Though there are exceptions, sharks typically have a tough skin that is dull gray in color and is roughened by tooth-like scales. They also usually have a muscular, asymmetrical, upturned tail, pointed fins, and a pointed snout extending forward and over a crescentic mouth set with sharp triangular teeth. Sharks have no swim bladder and must swim perpetually to keep from sinking to the bottom. There are more than 530 living species of sharks, taxonomically grouped into 14 to 30 families, according to different authorities. Several larger species can be dangerous to humans. The largest predatory sharks, such as the white shark and tiger shark, are often considered to be the apex predators, meaning without a natural predator or enemy, of their marine environments. Numerous sharks are fished commercially. However, overfishing in the late 20th and early 21st centuries substantially reduced the populations of some shark species. Shark species are nondescript in color, varying from gray to cream, brown, yellow, slate, or blue, and often patterned with spots, bands, marblings, or protuberances. The oddest-looking sharks are the hammerhead Spherna, whose heads resemble double-headed hammers and have an eye on each stalk, and Wobbegongs family Erectolobidae, whose skin, flaps, and protective coloration closely resemble the seafood. The vernacular of shark names indicate colors in living species, such as the blue Priones glauca, white Carcharodon carcharias, also known as the great white shark, and lemon Agapian brevirostris shark, the whale shark Rhynchodon typus, and basking shark Cedarinis maximus, both of which may weigh several tons, are harmless giants that subsist on plankton strained from the sea through modified gill rakers. Whale sharks may grow up to 18 meters, 59 feet, in length, whereas basking sharks may reach 14 meters, 46 feet, fully grown. All other sharks prey on smaller sharks, fish, squid, octopuses, shellfish, other invertebrates, and, in some species, trash. The largest among the more predatory species is a voracious 6-meter, 20-foot white shark, which attacks seals, dolphins, sea turtles, large fish, and occasionally people. The more sluggish Greenland shark, Samiosis microcephalus, of cold deep waters feeds on seals, large fish, and even swimming reindeer. They may also scavenge whale carcasses. Normally, sharks feed on fish, often attacking in schools. Open ocean species such as the mackerel, lamna, mako isurus, and thresher elopias. Sharks frequently feed near the surface and are much sought after with rod and reel for sport. Beautifully streamlined and powerful swimmers, those open ocean sharks are adept at feeding on fast tuna, marlin, and the like. Bottom-feeding species of sharks are stout, blunt-headed forms that tend to have more sluggish habits. The shellfish eaters among them have coarse, pavement-like, crushing teeth. Fertilization in sharks is internal. The male introduces sperm into the female by using special copulatory organs, claspers, derived from the pelvic fins. The young in many species hatch from eggs with the female and are born alive. Other species may lay eggs or nurture their young in the uterus with placental attachment to the mother, like humans. Some species may even consume their siblings before they are born. Sharks' geographic ranges are not well known. Their extensive movements are related to reproductive or feeding activities or to seasonal environmental changes. Tagging returns from large sharks on the east coast of the United States indicate regular movements between New Jersey and Florida, and blue sharks have been recovered after crossing the southern Atlantic Ocean. A tagged spiny dogfish, Squalus acanthias, was recovered after traveling about 1,600 kilometers, 1,000 miles, in 129 days. Advances in tracking technologies include the use of satellite tags that continuously beam a signal to orbiting satellites whenever the shark surfaces, and in that manner reveal north-south movements, transoceanic movements, and roaming and migratory patterns that are beginning to be understood for many species. Information on shark ecology and individual and group actions have provided increased insight into their behavior. Because large sharks feed on lesser ones, the habit of segregation by size appears vital to their survival. In a uniform grouping, dominance between various species is apparent in feeding competition. suggesting a definite nipping order. All sharks keep clear of hammerheads, whose maneuverability, enhanced by the rudder effect of the head, gives them a swimming advantage over other sharks. Sharks circle their prey, disconcertingly appearing seemingly out of nowhere and frequently approaching from below. Feeding behavior is stimulated by numbers and rapid swimming. When 3 or more sharks appear in the presence of food, activity progresses from tight circling to rapid crisscross passes. Under strong feeding stimuli, excitement can intensify into a sensory overload that may result in cannibalistic feeding or shark frenzy, in which injured sharks, regardless of size, are devoured. Sharks may abstain from food for long periods, and in captivity, they may refuse to feed. Feeding is inhibited in large males during courtship and in gravid females while on the nursery grounds. Areas selected for giving birth are usually free of large sharks. In locating food, the shark primarily uses the chemical senses, particularly the olfactory. Visual acuity is adapted to close and long-range location and to distinguishing moving objects more by reflection than by color, in either dim or bright light. Pit organs over body serve as distance touch receptors, responding to displacement produced by sound waves. Irregularly pulse signals below 800 Hz will bring sharks rapidly to a given point, suggesting acoustic orientation from considerable distances. See mechanoreception. Ampullary lateral line organs, electroreceptors. In addition, electroreception, the ability to detect minute electrical activities, works effectively at short distances in sharks. Electroreception may be the last sensory system used to direct sharks toward live prey just before they capture it. Feeding habits vary with foraging methods and dentition. Sharks with teeth adapted to shearing and sawing are aided in biting by body motions, including a rotation of the body, twisting movement of the head and body, or rapid vibration of the head. In coming to position, the shark protrudes its jaws, erecting and locking the teeth in position. The most feared species is the white shark, whose erratic presence in American coastal waters is associated with infrequent attacks along the California coast and elsewhere. Other sharks involved in attacks on humans are the tiger, Galeocerocuvier, bull, oceanic white-tip sea, Longimanus, blue, and hammerhead. Of course, the larger the shark, the more formidable the attack. But several small specimens can be hazardous as well, a fact well attested by seasonal attacks off the southeastern coast of the United States. Attacks on humans occur when sharks are hungry, harassed, or, in some cases, defending territory, though many interactions with humans appear more likely to be due to mistaken identity. Provocation is heightened by the kicking or thrashing vibrations people make in the water, which the sharks resemble the irregular movements of a wounded fish, the presence of speared fish or bait in water, or the presence of blood from wounds or menstruation. Most injuries occur on the lower limbs and buttocks. It has been estimated that there are about 100 shark attacks worldwide per year. Less than 25% of those are fatal, largely a result of hemorrhage and shock. It should be noted, however, that shark attacks are much less frequent than other aquatic mishaps. Among the threats from humans that sharks face is finning, the practice of harvesting the lateral and dorsal fins and the lower tail fin from shark by commercial fishing operations and others worldwide. After the shark has